dear students, welcome to KUTV. As we learn mathematics today, my name is Teacher Kelvin Wanyabura. So today we're going to learn a very interesting topic, and as we always start, we start with a word of prayer. Father, in the name of Jesus, we worship you for this lesson. May you help my student to understand what I teach them. In Jesus' name we pray. Amen. So today, my dear student, we are going to learn a very interesting topic in Form 4, and the topic is differentiation. So the subject is the most interesting subject, mathematics, and then our topic for today is differentiation. Differentiation. So to differentiate, because these are some of the terms that can be used. To differentiate means to get. To differentiate means to get the derivative. To differentiate means to get the derivative. The derivative. It also means to get the gradient function. To get the gradient function. The gradient function. It also means to get the derived function. To get the derived function. That is what to differentiate means. So, my dear student, I'm going to teach you how we differentiate a function or an equation, so that as we go to the subtopic that I want us to deal with, we will have the knowledge of how we normally differentiate our functions. So we're going to have an example of differentiation, and this is the example we're going to have. An example of differentiation. Example. So the question is, differentiate. Sometimes you'll be told differentiate, sometimes you'll be told get the derivative or get the gradient function, also the gradient function or the derived function. Differentiate y is equal to x cubed plus 3x squared minus 2x plus 5. So if you are told to differentiate y is equal to x cubed plus 3x squared minus 2x plus 5, you are going to get the dy over dx. How do we differentiate? This power here, you'll bring the power here. So this 3 comes here before the x. The 3 that is at the power comes here before the x. Then you minus 1 from the power. So you multiply by the power and subtract 1 from the power. So the power was 3. When you subtract 1, you'll get 2. So it's 3x squared plus this 2 comes here. There is a 3 here. There's a 3 here. So when this 2 comes here, it will be 3 times 2, which is 6x. Then this was power 2. So when you minus 1 from 2, you'll get 1. That is to power 1. If an x is to power 1, you don't write the power. Then minus. Now there is something I want us to get here. We are subtracting 1 from the power. We are subtracting 1 from the power. Now, what happens if the x does not have the power? If x does not have the power, then the x will cease to exist. If the x has no power, the x will cease to exist, so we'll have minus 2. What will happen to 5 that has no x? If you don't have x, you cease to exist. If you don't have x, if you are a number and you don't have x, I'm talking about the x of the number. If you don't have x as a number, you cease to exist. So our derived function will be 3x squared plus 6x minus 2. We are multiplying by the power and subtracting 1 from the power. If the x has no power, the x ceases to exist. If the number has no x, the number ceases to exist. That is how we differentiate. And B, differentiating an equation y is equal to x to power to power n, it means you bring n here. This is now the general way. dy over dx, the y will become dy over dx, is equal to, this n comes here, the power comes there, n, x to power n minus 1. So you bring the power here, and then you subtract 1 from the power. That's why we brought 3 here, and then we subtracted 1 from 3, and we got 3x squared. That's why we subtracted, we brought 2 here. When 2 combined with the 3 that was here, it became 3 times 2, which is 6. Then we subtracted 1 from 2, we got 1. And then, as I've said, the 2 had an x which has no power. If the x has no power, it ceases to exist. The 5 did not have x. If you don't have x, you cease to exist. That is the general way, or the general formula of differentiating. Now, we are going to a subtopic on differentiation. We see how now we apply differentiation. And the subtopic that I want us to deal with today is stationary point or turning point. Stationary point or turning point. That is what I want us to deal with today. Stationary points. Stationary points. Also known as turning points. Turning points. Stationary points, also known as turning point. Turning points of a function. Turning point. So before we do an example on turning points, I'm going to tell you what we do. When you're told to get the turning point, at stationary point, or at turning point, dy over dx is equal to 0. So if you are told to get the stationary point or the turning point of an equation, you differentiate that equation and equate the derivative to 0. That is what we call getting the turning point or getting the stationary point. At stationary point, dy over dx, that is the derivative or the gradient function, is equal to 0. Let us have an example. So we're going to have a 10 marks question, and the example, we call it example 1. Determine the stationary point or the coordinates. Determine the coordinates of the stationary points of the stationary points of the function, an equation, we call it a function in this case, of the stationary point of the function or of the curve, then we give the function of the curve. Y is equal to 2x cubed minus 3x squared, 2x cubed minus 3x squared plus minus 12x plus 8. My dear students, that is the question. Determine the coordinates of the stationary point of the curve. Y is equal to 2x cubed minus 3x squared minus 12x plus 8. So the first step, solution. So the first step is to note that at stationary point or at turning point, dy over dx is equals to 0. dy over dx is equal to 0. So we have to get the dy over dx of our curve, where we'll come and say we differentiate our curve. Dy over dx is equal to, remember differentiating, we'll bring these 3 here, there is a 2 here, so 3 times 2 is 6, So it's 6x squared, y squared. We subtracted 1 from the power. Minus, we bring these 2 here to this 3. There is a 3 here. So we bring these 2 here. Then we'll have 3 times the 2 that we have brought. It gives us 6. So it's 6x, yx, 6x, because we minus 1 from the power. When we minus 1 from 2, we'll get 1. If we have x to power 1, we don't write the power. Then minus 12x. 12 has an x that does not have a power. And remember we said, if the x has no power, the x ceases to exist. Inaisha. So we'll just have minus 12. Then there is plus 8. 8 has no x. If you do not have x, you cease to exist as a question, as a number, not an individual. So if the question, the number does not have x, the number will cease to exist. Therefore, my dear students, our dy over dx for this function is 6x squared minus 6x minus 12. And we say that stationary point dy over dx is equal to 0. Now, we are going to equate our dy over dx to 0. We're going to equate our dy over dx to 0. And then solve for x. And then we solve for x. So we come and say 6x squared minus 6x minus 12 is equal to 0. We can use any method of solving quadratic equation. We have the factor method, we have completing the square method, and we have the quadratic formula. So let us use the factor method of product sum factor. Before we use the factor method, we can simplify our equation by dividing by the common factor. Therefore, we are going to divide 6x squared minus 6x minus 12 is equal to 0. We divide by 6. We divide by 6, we divide by 6 everywhere. Therefore, we'll have our equation as x squared minus x, that is 1x squared, let me write the 1 there, minus 1x minus 2 is equal to 0. Factor method, product, sum, factor. Our product is the first number here times the last number. So our product will be 1 times negative 2, which is negative 2. Then our sum is the middle number here, which is negative 1. Our factors, my dear students, are 2 numbers that when you add them, you get negative 1, but when you multiply them, you get negative 2. Our factors are 2 numbers. When you multiply them, you'll get negative 2. When you add them, you'll get negative 1. So I know back at home as you watch this, you are trying to get those 2 numbers. Which are these 2 numbers that when you multiply, you'll get negative 2, and when you add, you'll get negative 1. Let me teach you how to get the numbers. I'm not just going to give the numbers. You will start by getting the factors of negative 2. Which numbers can we multiply and get negative 2? We have negative 2 times 1. Then we test that. Negative 2 times 1 is negative 2. Then we ask ourselves, if we replace the times with the addition sign, when you take negative 2 plus 1, are you going to get negative 1? If the answer is yes, then your factors will be negative 2 and positive 1. Therefore, the answer is yes. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. Therefore, our factors are negative 2 and 1. After getting the factors, we go back to our equation. The first term here, we'll just write it the way it is, x squared. 1x squared is the same as x squared. Now, instead of writing negative 1x, we replace with the factors. So it will be minus 2x plus 1x. This negative 1, we replace it by the factors. So we will replace and write negative 2x plus 1x. Then the last one will remain as negative 2 is equal to 0. So the first and the last remains, but the middle one we replace with negative 2x plus 1x. After that, we are going to group them. We group them into 2. We group them into 2 like that. What is common factor here? The common factor for the first group is x. You factor out x. You are left inside with x minus 2. Close the bracket. Then plus, what is common here? It is 1. 1 is common. Then you open the bracket and say x minus 2. Then you close the close the bracket is equal to 0. Now you realize there is x minus 2 here and there is x minus 2 here. There is a x here and there is plus 1 that is outside here. Therefore, you are going to take the x that is outside plus the one that is outside. They are outside, so you bring them together. And then the x minus 2, they are the same. This one and this one is the same. Therefore, you pick one and say x minus 2 is equal to 0. Then you pick the first one. X plus 1 is equal to 0. Take 1 to the other side. It was positive. It will be negative. Therefore, your first value of x will be negative 1. Then you take x minus 2 is equal to 0. Then you take these 2 to the other side. It was negative, it will be positive. Therefore, the second value of x is positive 2. So now we have two values of x. We have two values of x, and that is the first step, getting the values of x at the stationary point. But my dear student, a point is made up of x and y. A point is made up of x and y. Therefore, we are going to get the values of y when x is negative 1 and when x is positive 2. So, we hand our equation. And our equation was y is the original one, not the derived one. The original one was y is equal to 2x cubed minus 3x squared minus 12x plus 8. Now, we have already gotten two values of x. We pick the first value of x. When x is negative 1, what is the value of y? We substitute in our original equation, the equation of y, not the dy over dx1. We substitute where there is x with the negative 1 that we have gotten there. Therefore, we'll have y is equal to 2 negative 1 cubed minus 3 negative 1 squared minus 12 negative 1 plus 8. With that one, you'll be able to get the value of y when x is negative 1. So let us do it together. We have negative 1 cubed is negative 1 times 2 negative 2. Negative 1 squared is negative 1 times 3 negative 3. Times 3, negative 1 squared is positive 1. Negative 1 squared is positive 1. Positive 1 times 3 is positive 3. So, minus 3. Then, minus 12 times negative 1 is negative 12. So, minus negative 12 itakuwa plus 12. Then, plus 8. But my dear student, you don't have to do all what I've done. You have your calculator. You just insert the values the way they are in the calculator. Taking 2, open the calculator bracket, negative 1, close the bracket, cubed, minus 3, open the bracket, negative 1, squared, minus 12, open the bracket, negative 1, close the bracket, plus 8. So we'll have our y is equal to 12 plus 8 is 20. 20 minus 5. 20 minus 5 is 15. So our y is 15 when x is negative 1. Let us get the value of y when x is positive 2. When x is positive 2, so we'll come and say when x is equal to 2, how do we get y? Our y is equal to, we take our same equation here, 2, where we have x, we replace with the 2. So 2 cubed minus 3, 2 squared minus 12, 2 plus 8. So I have told you that you have your calculator, you just insert the values the way they are. But I am going to do them manually here. So 2 cubed is 8. 8 times 2 is 16. 16 minus 2 squared is 4. 4 times 3 is 12. 12 minus 12 times 2 is 24. 24 plus 8. 16 minus 12 is 4. 4 minus 24 plus 8. 4 minus 24 is negative 20. Negative 20 plus 8 is negative 20 plus 8 is negative 12. So our y is negative 12. Now you have the values of x and you have the values of y. You have the value of x, that is negative 1, and the value of y when x is negative 1, which is 15. We have the value of y when x is positive 2, which is negative 12. Now, to answer the question of the stationary point, you will come and conclude and say, therefore, the stationary points are, let me erase this one. You'll come and conclude and say, therefore, the stationary points are, therefore, the stationary points are, you start with the first value of x, negative 1, comma, its value of y. The value of y when x is negative 1, it was 15, and the next value of x was 2, and the value of y when x is 2, it was 12. So those are the stationary points. Those are the stationary points. The point is, differentiate, equate your derived function to 0, solve for x, get two values of x, and after getting the values of x, go to your original function of y, where there is x, substitute with the first value, get its value of y. Again, redo the same by substituting with the second value of x, get its value of y. After doing that, now you conclude and say, therefore, the stationary points are the first x and its y, and the second x and its y. That was part A of the question. Part B of the question is, for each stationary point, determine its nature. For each stationary point, determine its nature. For each stationary point, determine its nature. So that was question A that we did. So question B, for each stationary point, point, determine its nature. Determine its nature. Solution. So we'll pick the first point. Our first stationary point is negative 1, 15. Negative 1, 15. After taking your negative 1, 15, then you will come and draw a small table. Draw a small table like that. Your table has x, dy over dx, and it has dr, meaning diagrammatic representation. In this column of x, at the middle here, we write the value of x in our point. The value of x in our point is negative 1. So we write it at the middle. Now, behind it, you take negative 1 minus 1, it's negative 2. Ahead of negative 1, you add 1. You get 0. This is what I'm saying, my dear students. After coming up with a small table, we have x dy over dx and the diagrammatic representation. At the middle of x, you write the value of x of your point. Then you subtract 1 from negative 1, which is our value of x. You get negative 2. You write it behind the negative 1. Then you add 1 to negative 1. When you add 1 to negative 1, you get 0. You write it at the front of negative 1. Then when x is negative 1, dy over dx is always 0. So the dy over dx of negative 1, or the middle one, is always 0. The middle one, dy over dx, is always 0. Now we are going to get the dy over dx of these others. That is negative 1 and 0. How do we get them? Take your function, dy over dx function, the one we differentiated. It was 6x squared minus 6x minus 12. Take this one, not the first one, not the original one of y. Take the one you differentiated. Where there is x, you replace with this negative 2. So we'll have 6 negative 2 squared minus 6 negative 2 minus 12. I've said where we have x, we replace with negative 2. So I'll do it manually. Negative 2 squared is positive 4. Positive 4 times 6 is 24. Minus 6 times negative 2 is negative 12. So minus negative 12, then minus 12. So minus means addition. So 24 plus 12 minus 12. 24 plus 12 minus 12 is 24. So the value here is positive 24. Again, we do the same. We replace with 0. Where there is x in our derived function, we replace with 0. So it will be 6 squared minus 6 minus 12. So we are replacing now with 0 to get the value when x is 0, and our value when x is 0 is negative 12. So this is negative 12. So we have gotten a positive number, 0, and negative number. Positive, 0, negative, it's drawn like this, the diagram. Positive goes like that. Positive goes like that. 0 goes as a constant that way. Then negative goes downward that way. If we get positive, 0, negative, we'll conclude and say negative 115 is a maximum point. Negative 115 is a maximum point. When we get positive, 0, negative, it's maximum point. Let us do the same for the second point, 212. Let us do the same for the second point, 212. So we're going to show that 212, we're going to get the nature of 212. 212. Now that you have done for the first one, as we do for the second one, that is 212, I know now it will be flowing. Again, come up with a table. Your table has the values of x. It has dy over dx, and it has diagrammatic representation. My dear student, what is the value of x that you are going to write at the middle? I know back at home you are answering that it is 2. 2. That is our x in the point. Our x in the point, we write it at the middle. Then we minus 1 to get the x that you are supposed to write here. 2 minus 1 is 1. We add 1 to get the value of x that should be here. We add 1 and get 3. At the middle, my dear student, what is the value of dy over dx? Yes, yeah, you are answering it. It is 0. It is always 0. The middle dy over dx is always 0. Then how do we get the value of dy over dx when x is 1? Take your derived function. Your derived function dy over dx was 6x squared minus 6x minus 12. In our derived function, where we have x, we substitute with 1. So we'll have 6, 1 squared minus 6, 1 minus 12. So this will give us 6 minus 6 is 0. 0 minus 12, negative 12. You write there negative 12. Then you do the same. You do the same for the value of x, which is 3. dy over dx, so it will be 6 into bracket 3 squared minus 6 into bracket 3 minus 12. So 3 squared is 9. 9 times 6 is 36. 36 minus 9 times 6 is not 36, is 54. Minus 18 minus 12. So 9 times 6, 54, minus 18 minus 12, you get 24. You get 24. You get 24. So you write here 24. What kind of a point are you going to get? Negative 0, positive. If it's negative 0, positive, it's written like this. Negative slopes like that, the diagrammatic representation. Negative 0, positive. If it's negative 0, positive, we call it a minimum point. So we'll come and conclude and say 212 is a minimum. 212 is a minimum point. And that will be the answer for part B of the question. So my dear student, we have learned about maximum point and minimum point. Let us look at other 2 points. There is another 1 point that occurs as a result of 2 kind of natures. Let us see how we do it. So we have maximum, minimum, and we have other point that we call point of inflection. So if you get positive, 0, negative, it slopes like this. Positive, 0, negative, this is called a maximum point, as we have seen in our example. Maximum point. That is 1. 2, if you get now negative, 0, positive, negative, 0, positive, this one we'll call it minimum point. Minimum point. If you get it as positive, 0, positive, it slopes like this. Positive, 0, positive, positive, 0, positive. Or you get negative, 0, negative, which slopes like this. Negative, 0, negative. These 2 points, these 2 kind of points are called points of inflection. Point of inflection. Point of inflection. That is all about the nature of the stationary point. One more thing that you can be asked to complete the 10 marks of the question is sketch the curve. That is part C. Part C of the question. Sketch the curve. Sketch the curve. So we're going to sketch the curve. So that is part C of the question. Sketch the curve. So you've not been told to plot. My dear student, you've not been told to draw an accurate curve. They just need to see whether in the sketch, I want to insist on this, what do we mark when we are sketching a curve? we mark where the curve is turning. Is your curve turning at the point that you have just gotten? So this is how the sketch will look like. We have our 2 points. The first point was -1, 15, and the second point was 2, 12. So we're going to sketch a curve. You draw the x-axis. You draw the Cartesian plane. We have the x-axis. And we have the y-axis. We have the x-axis. And we have the y-axis. This is the y-axis. This is the y-axis. And this is the x-axis. 0. The highest value of x is 2. So you can say 0, 1, 2, 3, 0, -1, -2, -3. We are sketching our curve. Then on the y-axis, the highest value is 15. The highest value of x is 15, of y is 15. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 13, 14, 15. So -1, 15. I want us to see it. -1, 15. -1, 15, you mark there. -1, 15. Then we have 1, 12. Then we have 1, 12. Was it 12 or -12? What did we get? Our value of y when x, our value of y when x was -2. Was it 12? You see, I've erased what we got. Let me confirm. It was -12. It was -12. 2 -12. 2 -12. So we have now to extend -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. So you have plotted -1, 15 there, -1, 15. Then you plot +2, -12. It's down here. +2, -12 is there. Then you draw a curve, and your curve must turn at this point and this point. I am concluding. So your curve will look like this. We want to mark here and here. So you'll come and make sure your curve turns that way there. Then your curve comes and turn again at 2, -12. So this is how your curve should look like. That is how your curve should look like. Whatever is here and here is not important. What is important, my dear student, is does your curve show that it turns at this point? Because this is the turning point. -1, 15. Does your curve again shows that it turns again at this point? +2, 12. So that is how we do questions on stationary points. Stationary points. As I conclude, I'll read some of the messages that you are sending. Yeah, thank you. Hello, Teacher Kelvin. It's Ken from Muranga. Your explanations of the concept is perfect. I have understood. Thank you, Ken. Hello, Teacher Kelvin. It's Joy from Nakuru. You are teaching so well. Honestly, I have understood maths. I've never understood maths, but today I have understood. You are the best teacher. Thank you, Joy from Nakuru. And the last text is from, hi, Teacher Kelvin. It's Grace from Eldoret. What about displacement, velocity, and acceleration? Can you kindly teach that? On stationary points, I have understood very well. Okay, in the next lesson, we'll do, we call it application in kinematics. We'll do displacement, velocity, and acceleration. as I conclude, my dear student, I am an author. I have written 3 books, and I want to show you one of the most important books. This book is called Boosting Mathematics Performance. Boosting Mathematics Performance, KCSE revision book. This book contains both paper 1 and paper 2 of mathematics, which are divided according to papers and sections, that is section 1 and section 2. The book has questions which are well explained, including the question that I've just taught here. It's in this book, well explained, the explanation, worked out examples, and also a question for you to test yourself. It also has 10 speed tests to test your speed in doing mathematics. The book is Boosting Mathematics Performance, and it covers all the work from Form 1 to Form 4, divided in papers, paper 1 and paper 2. My first book that I wrote is Never Give Up. Never Give Up is a play on overcoming challenges of life. That was my first book that I wrote. The second book that I wrote was With God All Is Well, which is also a novel on overcoming challenges of life. And then the most important one for students is this one. To access any of my books, you can contact me through 0705 845 747 to access or to get a copy of any of my books. Or also to ask me any mathematics question, you can contact me through 0705 845 747. Thank you very much, my dear student. May God bless you abundantly, and all the best to all the Form 4 candidates of this year. May God bless you abundantly. My name is Teacher Kelvin Wanyabura. God bless you.
This program is rated GE. Content carried in here is suitable for general family viewing.
Habari watoto! Asanteni kwa kujiunga nasi. Katika kipindi cha leo tutakuwa na Nuzo, Namia na Bubelang tukijifunza jinsi ya kujiamini, namna ya kuweza kutengeneza picha kwenye akili zetu wakati tukisoma vitabu,
na jinsi ambavyo kusoma vitabu kunaweza kutupeleka sehemu nzuri mpya ambapo tunaweza kutengeneza picha kwenye akili zetu, kucheza na kutengeneza marafiki wapya.
Na baada ya kusafiri na Nuzo, Namia na Bubelang, tutasikia kutoka kwa watu mbalimbali wa Eswatini. Watatupa hadithi zao nzuri zinazohamasisha.
Ndio!
Mko tayari?
Tupo tayari.
Twende tukaanze kipindi chetu sasa.
Yes!
Ni huku.
Nuzo na Namia walikuwa na bibi ya mpendwa. Usafiri alipenda na hadithi zote aliwapa. Kila siku moja kafariki, hadithi za Bubelang zikawa zisikiki. Nuzo na Namia wakahamia kwa bibi za upya wa kusita. Wao ni jasiri, safari zikaanza. Kabati la bibi si la kawaida. Nuzo na Namia wanasafiri nasi sote.
Haya, jinsi ya kutengeneza ndege. Hatua ya kwanza, anza na karatasi ya mraba. Ninayo hapa. Hatua ya pili, ikunje karatasi. Sawa, nafanya hivyo. Tayari. Hatua ya tatu, kunja kona za katikati. Tayari. Hatua ya 4, geuza tiara. Geuza tiara? Tiara ipi tena? Mi siwezi.
Analia.
Nani analia? Kaka yako?
Analia.
Hebu tukaangalie kinachomfanya alie. Nini shida Nuzo? Njoo. Usijali, si vibaya kulia mwanangu. Ndiyo mwanangu, Nuzo analia. Umeshamaliza kulia Nuzo?
Ndiyo.
Sawa. Nini shida?
Baba, nashindwa kutengeneza ndege kwa kutumia karatasi.
Nasikitika kusikia kwamba unajisikia hivyo. Ila ukiniuliza mimi, naona umefanya vizuri sana.
Lakini ndege ana mabawa. Karatasi yangu hairuksa, siwezi kutengeneza mabawa.
Ila najua kwamba ukiendelea kufanya unachofanya, taratibu utafanya vizuri zaidi. Na kuaminia mwanangu. Wewe unaamini kwamba unaweza? Sawa. Sasa unaonaje tuchague mchezo mwingine kwa sasa? Wakati mwingine inasaidia kujaribu kitu tofauti.
Kama nini?
Nina wazo lingine. Hii ni nyumba mpya, si ndio? Nyumba ya bibi yenu. Mmewahi kukiona?